What's up, people? I'm back. Here we are, Key Concepts, my favorite page. Here we are. We're on page 54. That's a 5, then a 4 in your workbook, folks. Let's say you fell asleep. Let's say you weren't here. Let's say who knows what happened. Here's everything you need to know about 1/8. Okay? Again, we're talking about really, really, really big numbers, really small numbers, writing them with powers of 10. All right? Try to make this a little bit bigger. Again, Mr. Noel and I, we adapt, we change, we adjust, we get better. Hopefully the lighting's good. Hopefully you can hear me better. When would you use a power of 10 to estimate a quantity? When would we use a power? Well, think about all those different kind of numbers we had, right? So I would just say we will use them. Boy, that's sloppy writing there, isn't it? There you go. We will use them, I would say, for very large and small numbers. Okay? So large number, positive power. Small number, negative power. Cool? Yeah, I want to get rid of that writing. All right. Let's see what Kim does here. Kim writes an estimate for this number, right? This number here. See if we can't make that a little bit bigger. Boing, boing. Yes. I think that's great. All right, so here we go. And she writes it as 4 times 10 to the third power. Woo, can't even talk. Explain why this cannot be right. Why is she wrong? Oh, I know. It's because she didn't use this 3 and this 6 here, isn't it? She's got to have like 436 times 10 to... No? No, that's not right? Did you guys figure it out yet? Yeah, what do you got? Oh! Yeah. Small number should mean a negative power, guys, right? So... numbers, right, less than 1, right? So numbers that are less than 1, bigger than 0, have negative exponents. You thought you were done with negative exponents. Ha ha! Tricked you. Okay? But yeah, numbers that are less than 1 but bigger than 0, right? All those numbers there should have negative powers with it. So this should be 4 times 10 to the negative third power. Come on, Kim, you're better than that. Alrighty, my friend Raquel estimated that number there as 3 times 10 to the 8th power. What error did she make? I think she made an E. Did she make an error? Look, people. Look, what? Look, here, I'll zoom in more. Count the zeros with me, people. Count the zeros. 1, 2, 3, 4, 5, 6, 7, 8. Seems perfectly fine to me. We got this number here. We know that 0 ain't going to round it up. I don't think she did anything wrong. Prove me so. Yep, she good. Wait a second. I got to do something with these things here? What? I don't know. Yeah, think about this, people. If we were going to write this rounded number that we would use, right, it would look like this, right? We would look here at the 3. That 0 not going to round it up, right? It's just going to be a 3 within that's zeros, and now these are zeros, right? That's really the number we want. So no, guys, you cannot just count the zeros in there like I tricked you. I know some of you thought that we were right, like, hey, she didn't do nothing wrong. 8 zeros, power of 8. You got to look at your rounded number. Because look, now this 4, this 9, those turned into zeros as well, right? So we should get a 3 times 10 to what power here, guys? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This should be to the 11th power, okay? Okay, so that was good, right? I like all that stuff we just did there. All right, let's move on to our doing questions. Those were our thinking questions. Man, I like when I'm like super zoomed in here. This is great. Use a single digit times the power of 10 to estimate the height of Mount Everest. It's the tallest point in the world, in case you didn't know. Ask Mr. Knoll about his trip to Mount Everest, right? He's got a really good story about it. Don't have enough time for it right now, but if you're a Knoll kid, you can ask him, or if you see him in the hallway, good to go. We're going to round this to the nearest 10,000 feet. Okay? So here's our number right here. Bam. Okay? So round that to the nearest single digit power of 10. So we look at the 2. We're going to round to that 2. Does the 9 round it up? Keep it the same. Yeah, it's going to round it up. So this should be a 3. Right? Times 10 to what power? Well, these are all going to turn into zeros. Don't be like Raquel and just count them. We got 1 0, so power of 1. 1, 2, 3. We're going to have 4 on there. Bam. 3 times 10 to the 4th power. Got it right. Okay? Yes, yes, yes. More questions. Love this. Are you kidding me? Who? Look at this silly number here. What is this? A scientist records the mass of a proton. I don't even know what a proton is. Maybe we could talk to Miss Lindsay about this, right? I think we got protons, electrons, neutrons. Jimmy's in there somewhere. I don't know. Okay. Use a single digit times the power of 10 to estimate the mass. Okay. So again, we're gonna look in here. I got a whole bunch of zeros. Finally, I come across my single digit right here, 1. Then I've got a 6. Is this 6 going to do anything to the 1? Yeah, it's really going to make it a 2. Okay? Again, I don't care about all these. They all turn to zeros. We ain't worried about that. We got to be a good counter here. Count how many place values we have here, folks. Holy smokes. Okay, so we know it's going to be 2 times 10. Look, we know it's going to be a negative power because we're dealing with a super small number here. All right, I'm just going to do a little mark so I can count this right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Wow. That is a ridiculously small number, okay? But there it is. So 2 times 10 to the negative 24th, right? And guys, start to think about, like, man, that's a super small number. That's a crazy big power. When we think about negative, like, 24th power, holy smokes. Okay? All right. Good news. Last question on the key concepts here. Talking about the Georgia Aquarium, also known as the Peach State. That's right. Georgia peaches. They send them all throughout the United States. They're super good. Anyway, the Georgia Aquarium holds approximately that many gallons of water. Again, approximately means about. The tanks at the Audubon Aquarium of the Americas have about this many gallons of water. Okay. Use a single digit times the power of 10 to estimate how many times greater the amount of water is at the Georgia Aquarium. Okay. Again, they gave us this one here. Hey, 8.4 times 10 to the 6 gallons of water. We need to take, this number here, 400,000, and we need to make that into a number that looks like this. Okay? Let's do that. Single digit times the power of 10, guys. Again, here's the first one, 8.4 times 10 to the 6, right? That's the Georgia Aquarium. 400,000. Is the 0 going to do anything to the 4? No, going to keep it the same. So this is going to be 4 times 10 to what power? 1, 2, 3, 4 to the 5th power. All right? There you go. So here's my two numbers. Obviously, 8.4, 10 to the 6th, much bigger number. How much bigger? It says estimate. How many times greater? Okay, well, let's just get rid of this 4 here, right? If you think about rounding, guys. Oh, no. Should we join a Zoom meeting? No, what the heck just happened? Who even knows? Maybe my computer's updated. Computer, what are you doing? We were going along great. Okay, now we're back. So guys, we're going to get rid of this 4. Remember, if this was a 5, we would round that up to a 9, but it's not, it's a 4. Like, we're talking about a large number of gallons, okay? So I want to get rid of this. Now I'd like us to, look at these numbers, right? We know this is the bigger number, but, how much bigger is this? Well, if we just look at 8 and 4, how many times bigger is 8 than 4? It's 2 times bigger. Okay? How many times bigger is 10 to the 6th than just 10 to the 5th? Well, it's 1 power of 10 bigger, right? It's 1 power of 10. What's 2 times 10 to the first power? 2 times 10. Well, that's just 2 times 10. 2 times 10. That's 20, right? So there you go. So it's roughly about 20 times greater, right? The Georgia Aquarium, when we talk about how much water's in there, compared to this Audubon Aquarium of the Americas. Okay? So this is where we're going, my friends, right? When we get into 1.9 and 1.10, now we're going to start to do stuff like this, right? With these things. We're going to be comparing them. How many times greater is it? I'll give you a hint. All right? When you see this, how many times greater, I want you to think of this math problem, okay? How many times greater is the number 10 compared to the number 2? Look, I know most of you are probably going, okay, well 10, how many times greater is it than 2? Well, 10 divided by 2 is 5. Well, yeah, guys, that's the right answer. It's 5 times greater. So we're always going to do dividing when we see this. Bigger number divided by the smaller number. Okay? Anyway, a little bit of a tangent there, but I think you guys get the point. I think we should be good on key concepts now. So we should be getting into our additional practice here. And, again, if you got questions, let Maylee or Noel or I know. But anyway, hope you enjoyed it. See you soon.